Today we are going to continue with our Learning Target 1 from Unit 7, which is I can define and represent transformations using various tools. And we're going to be focusing on rotations. And a rotation is a turn around a fixed point called the center of rotation. So the figure rotates at a specific angle and direction. So when we're talking about the angles, we're going to be focusing mainly on 90 degrees, 180 degrees, and 270 degrees. And then directions are either going to be clockwise or counterclockwise. Obviously, know that you can rotate figures at any angle. However, we are going to focus primarily on 90 degrees, 180 degrees, and 270 degrees. Though the figure can rotate around any fixed point, the most common center of rotation is the origin. So 0, 0, the center of our coordinate grid. So our rules for rotating about the origin, and this is important because these rules only work if you're going to be rotating about the origin. If you are going to be rotating 90 degrees counterclockwise, so that would be going to the left, you're going to take your ordered pair that you have, so your x comma y, and you're going to reverse the values, and the y value that's now in your x location is going to become the opposite of what it was. So you switch the ordered pair, and then your first term, your new first term, becomes the opposite. With 180 degrees, again, if we start with x comma y, you are going to keep the x and y where they are. However, they are both going to become the opposite of what they were. And lastly, if we are talking about 270 degrees counterclockwise, so that would be 3 turns to the left if we're looking at our grid broken up into 4 sections, and that would be our rule. X comma y would change to, again, we would switch the x and the y. However, this time the original x would become opposite, or the new y would become opposite of what it was. So looking at example 1, we're going to graph and label each figure and its image under the reflection in a given rotation about the origin. Okay, so go ahead right now and graph the pre-images, so rectangle PQRS, triangle ABC, and triangle LMN. Go ahead and graph those 3, and then we will come back and I will talk through how we are going to rotate those. Okay, so hopefully you were able to graph your pre-images accurately and make sure that you're labeling them with the values of P, Q, R, S, A, B, C, and L, M, N. All right, so if we look at our first example here, rectangle PQRS, it's technically a square. We are going to rotate it 180 degrees. Notice with 180 degrees, we don't specify clockwise or counterclockwise because regardless of which direction we're rotating it, it's going to end up in the same spot. So with 180 degrees, you do not need to worry about which direction you move. However, with rotations, if it does not specify a direction, you assume counterclockwise, which might be a little backwards in your thinking, but either way, if it does not say, like if it just said rotate 90 degrees, you're going to be rotating 90 degrees counterclockwise. All right, so for 180 degrees, that would be 2 90-degree turns. And remember, in our grid, one quadrant is 90 degrees. So if I'm rotating 180 degrees, that is 2 90-degree turns. So my figure is going to map into that third quadrant. All right, and if we go up to our rules, so if I'm rotating 180 degrees, I can see that my x and y are going to stay exactly where they are. However, the values are going to become the opposite. So for the image of P, instead of 2, 6, it's going to be negative 2, negative 6. So negative 2, 1, 2, 3, 4, negative 6. That's going to be my image of P. If I look for Q, that's at originally the pre-image is at 6, 5. So it will now, your image will be at negative 6, negative 5. R, your image of R, would be at negative 5, negative 1. And your image of S would be at negative 1, negative 2. And then you can go ahead and graph that. So let's see, negative 1, negative 2. That would be your image of S. 1, 2, 3, 4, 5, negative 1. That would be your image of R. And then negative 6, negative 5, 1, 2, 3, 4, 5. That would be your image of Q. And we should be able to see that we have a congruent shape. Again, remember that rotation is another example of a rigid motion, so the pre-image and image should be congruent. All right, if we are looking at our second example, triangle ABC with vertices where we have them, and we are going to be rotating 90 degrees counterclockwise. Okay, so counterclockwise again would be turning to the left. And since it's 90 degrees, that's going to be one turn. So our image should end up in quadrant 2. If we look up to our rules for 90 degrees counterclockwise, that is going to be this first row here. So we are going to reverse the x and the y, and then the original y is going to become negative. So looking at A, it was at 2, 7. So if I flip those, so it would become 7, 2, and that 7 would become negative. For B, it was originally at 6, 5. I'm going to reverse those, and the 5 would become negative. And then for C, if I reverse those, that means the 1 would become negative. Okay, and then you can go ahead and graph that. So if we go to negative 7, 1, 2, 3, 4, 5, 6, 7, up 2, and again, be sure that you're labeling with your tick marks to represent that it is the image. 4, 5, 6. And negative 1, 1, 2, 3, 4. And that is C, image of C. And so we can see that we have our rotated image in quadrant 2. For our last example, it says triangle LMN has its vertices, which we already plotted, and we are moving 90 degrees clockwise. Now, our rules do not follow clockwise motion, because again, that's not the way that we assume when we are rotating. However, we can use a little bit of logic. So if 90 degrees counterclockwise is one turn, or well, let's think of it this way. 90 degrees clockwise, it would end up in one turn going to the right. Well, which one of our rules would have an example of the pre-image mapping into the fourth quadrant? Well, that's going to be 270 degrees counterclockwise. So you can think of this as 90 degrees clockwise, which would mean 90 degrees counterclockwise is 270 degrees clockwise. And as we discussed, 180 is the same regardless of the direction we're moving it. So if I'm looking at my rules for 270 degrees counterclockwise, which is the same as 90 degrees clockwise, I'm going to be reversing the order of the x and the y, and then the original x is going to become negative, or you could think of it as the new y is going to become negative. So if L was at 1, 5, I'm going to flip those. It would become 5, 1, and then the original x would become negative, or the new y would become negative. For M, it was at 3, 8, so it would now be at 8, and then negative 3. And N, if I reverse those, it would be at 1, negative 8. And then you can go ahead and graph those. 2, 3, 4, 5, and then negative 1. That would be your image of L. go to 8, -3. That would be your image of M, and then 1, 2, 3, 4, 5, 6, 7, 8 would be at that location. And then connect, and you can see that you've rotated your figure 90 degrees clockwise. Now, that is when you're rotating about the origin, but we are not always going to be asked to rotate about the origin. Sometimes we are going to be rotating around a different point. This is not as common, however, it's important to understand how to do that so that when you do encounter it, because you will encounter it in your mathematical career, just so you have a general idea. Now, when I teach this in 8cc, I know you guys didn't get the benefit of that using the summer class, but there is tracing paper that can help you with this. However, we're going to talk about the more logical way of doing it, or the more thought-provoking way of doing it. So if we're rotating about another point other than the origin, it says a figure can be rotated about any fixed point. In the example to the right, ABC, triangle ABC is rotated at 90 degrees counterclockwise about point P. So notice it's a completely separate point that's not our origin. So in order to do this, we're going to be using vectors, which we talked about in our last section, or yesterday, relating to, or 2 days ago, sorry, with translations. And vectors to be able to translate. We're also going to be using vectors to help us rotate. So the steps to rotating about other fixed points: you're going to graph the pre-image and the center of rotation, write the vectors formed from the center of rotation to each vertex in component form, use the rotation rules about the origin to rotate the vectors, and then use the rotated vectors to plot the image, graph the coordinates of the image. So we're actually going to go through this step by step, because that's a lot of words that when you just read them, it sounds relatively confusing. However, I think once you see it in action, you'll be able to pick it up pretty quickly. Okay, so the first thing that we want to do is go ahead and graph our pre-image for triangle XYZ with vertices X at 4, 7, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. That's your X. Y is at 8, 5. That's your Y. Z is at 6, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3. And so that's Z, and we can connect our points. And we can see triangle XYZ. Okay, and then our point of our center of rotation is actually going to be at 1, 2, which is right here. So that is point P. And that is our center of rotation. So what we need to do is we're going to find the vectors from the center of rotation to each vertex in component form. So our first vector that we're going to look at, let's do P to X. So vector PX, I'm going to write that down here, vector PX in component form. We are going to move right 3 and up 5, so that would be 3, 5. Our vector PY, so PY, that's going to be right 7 and then up 3, so that would be right 7, up 3, and then our vector PZ would be, let's see, right 5, up 1, so that would be 5, comma 1. Okay, so now in order to find where our new ordered pairs will be, we are going to follow the rules for rotating about the origin for 90 degrees clockwise or counterclockwise. Okay, so if we go back up to that first page, 90 degrees counterclockwise, we are going to switch the order, and then the first term is going to become the opposite. So, and I'm going to have to write that over to the left here. So my vector of p x prime is going to be -5, 3. My vector for p y prime is going to be -3, 7. And my vector for p z prime is going to be -1, 5. So now, to put this into play, starting at P, I'm going to go to the left 5. So for my first vector here, I'm going to go to the left 5, 1, 2, 3, 4, 5, then up 3, 1, 2, 3. And that is the location of x prime. Okay, if I look at vector p y prime, starting at P, I'm going to go 3 to the left, 1, 2, 3, and then up 7, 1, 2, 3, 4, 5, 6. I'm going to go off my grid here, 7, and that's going to be where y prime is going to land. And then if I look at P, z, the vector P z prime, you're going to be going 1 unit to the left and then 5 up. 1, 2, 3, 4, 5. And that is where z prime is going to be. And we can see that we have just translated, I'm sorry, not translated, we have just rotated triangle XYZ 90 degrees counterclockwise about 0.12. So if I'm looking at my ordered pairs, X is now at 1, 2, 3, 4, 1, 2, 3, 4, 5, -4, 5. Y is at -2, 9, and Z is at 0, 7. Okay, I want you to go ahead and map out or record or write down the pre-images on the next two examples, and then we will come back together. Okay, so looking at our next example with rectangles C, D, E, F, we're going to go ahead and find what are the vectors in component form from A, which is our center of rotation, to each of the points in our pre-image. So we can have vector AC, we're going to have vector AD, we're going to have vector AE, and vector AF. And vector AC, oh, that was not good. Oh my gosh, arrow. So vector AC, that is going to be -4, 7. Vector AD, so we would go to the right, or to the left one, and then up 7. For vector AE, we're going to the left 1, and then up 2. And for vector AF, we are going to the left 4 and up 2. So then in order to rotate 180 degrees, we're going to take those vectors written in component form. And remember, our rules for a 180 degree rotation is we are going to keep the values where they are, however they are going to become the opposites. So a vector AC prime is going to be +4, -7. And vector AD is going to be +1, -7. Oop. Remember, these are not parentheses, they are the little arrows. Okay, for vector AE prime, it's going to be a positive 1, negative 2, and for vector AF prime, it's going to be a positive 4, negative 2. All right, and then if we go ahead and graph those, so starting at A, if I go 4 to the right, 1, 2, 3, 4, down 7, 1, 2, 3, 4, 5, 6, 7. My image of C is going to be right there. Again, make sure that you're labeling it properly. Okay, if I go then for AD prime, I'm going to go 1 to the right, down 7, D prime. AE, I'm going to go 1 to the right, 2 down, and that's going to be E prime. And then for the vector AF prime, I'm going to go 4 to the right, 1, 2, 3, 4, and then 2 down, and that's going to give me F prime. And I should have a congruent rotated shape 180 degrees. Okay, and then you can just fill in what those points are. I want you to go ahead and try that last example, pause your video, and then check your work. Okay, so go ahead, take a look at your work for this. I am hopeful that you caught that it was a 90 degrees clockwise rotation, which remember is 270 degrees counterclockwise. So we were using the rules where you switched the x and the y coordinates, and then the second value switched to the opposite when you were doing your component form. So double check your work. If you have any questions, email me or stop by during office hours. I would be happy to help. If you're feeling good, head over to Delta Math and complete your practice there. Again, you'll have multiple opportunities to do a problem. I think I give you 2 options to check your answer before it actually marks you off for it. So that gives you an opportunity to kind of make sure you're doing it right. Make sure you upload your completed notes to Google Classroom, and I will talk to you later. Bye!